Hello, everybody. I am Mubot.
Mubot, what are you doing here? Go away. It's time to do some stats. Let's do this. What is going on, everybody? Mubot there, giving points. Mubot, time to give out some points. Let's go here and give away some points. Who is all here? What all questions do we have right here? Some points in the chat. Mubot, you awake? You're appearing on screen, but are you awake? We'll see if Mubot's awake to give out some points. So you're out here. Then we said you couldn't find him. Oh, yes. Replying to someone on the Discord. Feel bad. I meant to talk about the hey Layla and Sam, good to see you. Could you please explain where the 50% comes from the referendum problem? Still struggling to grasp it. Yeah, I've got that still up on screen. Let's go back over that. You got it. Chapter 7 comments content quiz. Yeah, let's look at that. Oh, I gotta stretch. Got my second cup of coffee. Here we go. So the reason we're doing less than 50% is, imagine if you take a poll, when will the poll be like predicting failure? When will the poll predict failure? When you have a poll that comes back, does that make sense here, Sam? That less than 50% of people are voting for the poll, or are saying that this will happen right here. So in a poll, if we see less than 50% of people voting for it, then we would have in our poll that we predict failure. Does that make sense, Sam? Mm-hmm. So this is why we're saying, what is the probability that the will lead to predicting defeat? So we'll predict defeat if in our sample that says the sample we see is less than 50%. So if the sample we see is less than 50%, which is this shade area on the curve right here, if in a sample we see less than 50%, this area right here, then we would predict defeat for the poll, because we'd say, well, this is what we would see right here. Mubot, and now he's giving out the points. I don't know why he's in the past. What happens if I go here and talk to Mubot? I have no idea. See, I can actually see what Sam's saying in the future. I do not understand. What happens if I do this? I'm going to type that in as the streamer right here. So that appeared really quickly, and then Mubot did it instantaneously. So weird. It does, but without help, I don't think I would ever... Yeah, it's a tougher problem. And like I said, I don't know if I would have gotten it immediately either. A bit of a tougher problem right there. I do agree completely. A bit of a tougher problem, especially with the last part about doing the less than 50%. But good stuff right there. But yeah, if you have another question, let me know. We're going to hop to the Canvas content. Let's do it. Let's go talk about that Canvas content number 7. Great job, everybody. Keep doing the work. Keep just on track. When you see the assignments, start them early. If you have questions, swing by office hours or check out the videos. Where's it gonna be? And then remember, I try to put the timestamps in as soon as possible. Canvas content number 7. We're nearing the end of Canvas content. Ooh, cover stuff from today. We got a preview of it. Let's head over to the main screen. Let's do it. We could try to set something up here. Okay. Can you go over chapter 12 light bulb homework problem? You bet. We'll do that right after this. Caitlin, you got it. The light bulb homework problem. Improbability, the value of each trial is called, the value of each trial is called a consequence. Now, I find this pretty weird. I don't know who wrote this one, because it's not in the notes. And I might actually delete this one. It better be false. Because we have a bunch of people working together. I want to see here real quick. Yeah, good. I'm about to say, because I've never seen that word. I hate these. I don't love this question. I'll tell you why. It's the outcome. That's the answer for what it is. It's an outcome. The probability of, or the value after each trial is an outcome. This is in the sampling notes. False questions are some of the worst ones, or some of the hardest ones. Here we go. Here we go with trials. Actually, it's going to be over here on probability. So it's an outcome. So when you have a false question, There it is right here. The value after each trial is called this. So it's an outcome. It's just weird when we change the words. Yeah, sure, Carly, put it in there. You know what we might do? Tell me if people would like this. I have an idea, and I want to try this out right now as we're working on this quiz. I want you to tell me if you like this idea or not. You ready? Tell me if you like this idea. Can I not do it on this? It's not that. No. Maybe I can't do it on this. Wait. Instant reply. 2 seconds to see if this works. There's a lot of things I didn't even know I could do. I thought I could do a scrolling text. You can do that in the other one. 2 seconds. Hey, what's up, Charlie? So good to see you here. I'm seeing if I can put a scrolling text. I'm gonna see if I can get a scrolling text on the bottom. I wonder if people like this. Here we go. Okay, they're just adding text. Him in the background talking. Okay, and it's a filter on the text. Okay. Tell me if you like this idea. So we're trying out a new experimental idea during office hours right here. So we need to go to a text, add source. Please enter the name of text. Office hour questions, and add source text. So the next question right here is, wait, that's so huge. Okay, let's go here first. And I don't know if this is going to work or not. I was trying to do the campus content 8, but mine still has only 2 questions. It is only, I tried it on different browsers, but all of them still have 2 questions. We might just be dropping that one, or I'll have to adjust it. It should be fixed now. Let me look at that here in a second, Ritu. I thought I fixed it yesterday. I don't know why it's broken. Let me go look at that here in a second right here. So the first question right now is, I'm trying to figure out the way to order this. It's so weird the way it's doing this because it's augmenting the text. Canvas content. Here we'll go first. See, it's going to be a lot updating this every time. And then we have here, let me put these in order. Chapter 7, and then we have, the next question was, see, this is a lot of work already. Light bulb, problem, second, and this also, it's not going to work. It's just not, yeah, let me delete that right there. That's not going to work. I was going to have that scrolling on the bottom of the screen so you could see what's coming up. I have a better idea on how to do it, so we'll worry about that here in a moment. And I might try to get that done during another time, like make these stream adjustments. Yeah, exactly. I'll try out new things. We do have a new thing that we just did at the end of class today, and here we'll get more serious. Put a cut in the video, because now we have...
Ubot can appear over here. Okay, let's get serious, everyone. Here we go.
Okay, let's get serious. Let's do this. Let's head back and do that canvas content. Okay, so we're doing the canvas content right here. I always hate those false questions because they're the trickiest ones because you can put anything as false. So the probability of a new marketing campaign has been successful in past history. Given for this, the company rolls out 5 new campaigns. What is the probability of at least one being a success? Ooh, this relates to, I think it was it Caitlin's question? At least one of these campaigns is a success. So this question is really tough right here. Let's look at this question. And we have the probability at least one is a success. And a lot of people will just look at this when they get to the test and they say, I got no idea. Would you agree with me that we have 2 possibilities? All are failures, or, put an order here, at least one success. And one of these things must occur. Does this make sense right here? That either all their campaigns will be failures, or at least one will be a success. Like when you think about this, like either all the campaigns will fail, or at least one will be a success. Does that make sense? And when I have one right here, I mean one of these things must occur. So who can figure out the probability of a failure? Let's just find probability failure is equal to what? Probability of a failure. So we've got what we need to find right here. Now we're going to figure out the probability of a failure. What is the probability of a failure? So we have the probability of success. I'll write that right here. probability of success is equal to this. What is the probability? Because either it's a success or a failure. Those are complements. So the probability of a success is this. What's the probability of a failure? The probability of a failure is going to be what now? What will the probability of a failure be? Because we know the probability of success is 30%. The probability of failure will now be what? 70%. Great job, Layla, right there. Great job. And so now we need to figure out they're all failures. So that means the first is a failure, and the second is a failure, and the third is a failure, and the fourth is a failure, and the fifth is a failure. So computer simulations are necessary in simulation. Very true right there, Caroline. Great question, Carly right there. Sorry, Carly. That is a true statement. That is a very true statement. And so 0.7 and 0.7, what are we assuming for each campaign right here by multiplying these together, which we have to assume if we're multiplying. When we multiply things together, we have to assume that each campaign is what of the previous campaign, which is a kind of a big assumption. We'll assume it. Response bias is always possible in a story that requires it. Very true right there. Very true. What do we have to assume right here? They're independent, and that's the rule of independence when we multiply. Whenever you multiply things, they're independent. Whenever you add things, they need to be disjoint to easily add or multiply events. Review the lecture on that to make sure you understand multiplying. We have to assume independent. Great job, Charlie. Great work right there. Let's throw some 20 points. Charlie notes some answers in the chat. I think Charlie's got some pretty awesome points. And so now let's go ahead and solve this, because this is the probability they're all failures right here. So the probability all failures is just 0.7 raised to the fifth. And now we can just mathematical change this to a plus, and then we can just bring this over here to the other side. And that's the answer. Here's the answer to the question. The probability of at least one success is everything but, because one is everything but, maybe we can do it towards the end probably, because that'll be next week. So with test 2 coming down the line, I'm going to take as many test 2 related things, and then we could maybe get to that. Be more towards the end. 2, 3, 4, 5. I can send you some stuff if we don't get to it. Like if you're like, hey Brian, can you send me material over it? I've got some videos going over it, so I can make sure we have some videos. And so there's the answer, and there's the rounded, and that's got it. Long thing for a multiple choice. In probability, the value of each is a consequent. No, it's an outcome. Sampling distribution rules allow us to calculate a confidence interval for the population proportion. So these are the same rules right here of sorts. And so basically we have the random condition, the 10%, and the success failure condition. So the sampling distribution rules and conditions allow us to calculate a confidence interval for the sample proportion. It's basically still the success failure condition. I think over which one of my colleagues wrote this. All other things being equal, the larger the sample size, the smaller the standard deviation of the sampling distribution. This is a very true statement right here, because what are we doing when we change the sample size? We are changing the what of these equations. So we see the sampling distribution of the sample proportion here. This was a my Pearson problem we were doing. If we change the sample size, we are changing what about this? We're going to make it only so we see the things on the screen we're talking about. All else being equal, larger sample size equals smaller standard deviation. So what are we changing? So there's the standard deviation. Here's the standard deviation. And it says all else being equal, larger sample size. So what are we changing if we're increasing the sample size? And just think about it, you're dividing by it. So all else being equal. All else being equal. What are you changing? N gets bigger, exactly. Larger sample size, and that means you're dividing by this. So it's going to make a smaller standard deviation. And this is going to be important for the central limit theorem, which states the distribution is going to be more normal and tighter. And this is going to make it tighter as N increases. So I believe it said all else being equal, the larger the sample size, the smaller standard deviation for the sampling. That's true. The success failure condition for a confidence interval for proportions requires there to be at least 10 successes and at least 10 failures. The 10% condition is no more than 10% sampled. I'm so afraid I'm going to blur my eyes on this, and there we go. This is the only one I paused on for a second here. I'm just like, with someone, because you could go like, really specific on this because one of them's NP, NQ, one of them's NP hat, NQ hat. But when you look at the notes right here, especially the notes I provide, which literally will tell you the answer, because I would have gotten really mad if that one was wrong. In the notes we went over today, we went over all the conditions. And the conditions when we have categorical data, let's go right here. Go over here to the screen. The condition is success failure. And so this is a big thing we went over today. We always pause and we ask what kind of data are we dealing with. And this was for categorical data right here. This is for quantitative data right here. And this is for chi-squared. So really good notes on the conditions right here. So given that we have the success failure condition, so do the three conditions for sampling distribution need to be met in order to calculate p hat? No. Oh, no, that's no worries. No worries, Layla. To calculate the three conditions, meeting the three conditions mean that the distribution will be what? So we don't need the conditions to be met to calculate p hat. When we meet the conditions, we can then say that the distribution is going to look what? Random 10% and success failure. We can now say that the distribution will be about this. It'll look pretty this. Like the distribution is going to look pretty this shape because it goes towards when we meet all these conditions, it's going to look pretty this. And that's the goal of it. Then we can then use this curve right here to do the 68, 95, 99.7 and use things like z-scores. The big goal of meeting these conditions is that it looks approximately normal. Does that make sense? So the big goal, normal, yep. That's the whole goal right here, meeting these conditions, is that then you can see a lot of times I'm drawing the normal curve right here. By meeting the random, we randomly sample, less than 10% of the population is sampled. And success failure, we have at least 10 successes and at least 10 failures. We're going to draw the normal curve a whole bunch. And that's kind of the goal of meeting these conditions. Same thing down here, we can do the confidence intervals, and we need the normal curve. So you can see all the work we did here today using the normal curve and the z-scores. Does that, I think, so we should be good on... There's the Canvas content, a little help with the Canvas content, some questions in the chat. Getting those hundreds right there on Canvas content. You get 2 attempts. So good stuff right there. I'm going to look at Ritu's question with the 8th one. I'm going to see if it's fixed. Ritu was saying there was a problem with the 8th one, and I did see that yesterday. Look at the questions again. No, it should have 4 questions right now. I changed it. No, pick 3 questions. Is it... Let me see something. No, it should have all 5 questions, Ritu. Can you send me what you're seeing? I'm seeing over here it has 5 questions. I can show you. Here it is on my screen. Once again, don't use Safari. It's problems. And it has 5 questions right here. Please tell me if it has issues. I thought I fixed it yesterday. I went in and fixed it and changed around some stuff, make sure everything's working. Something must have just gotten disconnected. But I don't know why maybe it's because you had an older version. If you need more attempts, let me know and I can like fix it, save more attempts. Can you do the one investment website can tell us what differences, what devices are used? Yeah. Which chapter is that on? I think let me make sure. I think we might have had a problem or 2 from I think Caitlin had one, and then we'll do here we go. Lightbulb problem. Let's do lightbulb problem, and then Layla, we can do that one right there. So let's go do Caitlin's lightbulb problem. And please remind me between things if I forget one of your questions. If someone's like, wait a minute, I had my... Don't worry. That's why I wanted to put the scroll window on there. I wanted to put the like scrolling questions. But I have an idea on how to do this also. I could try maybe at the end of office hours here to do my other idea. So I have another idea on how to get it working. And it could work. It could... see what happens. Chapter 12, quiz, lightbulb problem. I like the lightbulb problem one. The lightbulb problem is in at least one problem. The lightbulb problem is in at least one problem. Got it. Here we go over here. Chapter 13 quiz coming up next. And I think that's... Is that part 2 or part 1, Layla? Is it part 2 or part 1? Is it confidence rolls or is it... I think it's confidence rolls, right? Well, Layla will tell us, and then we'll do that one next. Here we go. Awesome, Carly. Let's do that next because we'll do Carly's question next. Then we'll do Layla's. Thank you, Carly, so much. We'll do Canvas content number 6 next. We'll do a version of it, and we'll throw a Canvas content on here. Part 1, awesome. So here we are with the light bulb problem right here. Now, what you want to do whenever you get a problem is you want to start marking the notation. I promise you, this helps me solve the problems to write down everything I see. Like, you want to take everything you see in the problem and then put it over here on a document or something and start writing down like your notation. This has helped me so much just to see it and do it. So you notice right here first we have the probability that a light bulb does not work. So this is going to be the probability of broken. So we've got the probability a light bulb is broken, and we have a probability that the light bulb is working. So the probability a light bulb is broken is this. The probability a light bulb is working is this. So we have the two associated probabilities. Either a light bulb is broken or it's working. You could say broken or not broken. So, or there we go, not working. So either a light bulb is not working or a light bulb is working. So we want to find out what is the probability at least one of our light bulbs is defective when we buy a 5-pack of light bulbs. So this is where the problem gets a little more complex. You're going to buy 5 light bulbs. So let's go ahead and buy a 5-pack of light bulbs. It's going to look something like this right here. 1, 2, 3, 4. We buy another 5-pack of light bulbs. 1, 2, 3, 4. Go to not blocking it. We buy another 5-pack of light bulbs. 1, 2, 3, 4. Now, in these, we got the light bulbs that work. And we have the light bulbs that do not work. Now, I want you to think through this right here. Here's the light bulbs that do not work. We bought 3 5-packs of light bulbs. Looking at Brian's light bulb packs, 1, light bulb pack 2, and light bulb pack 3, in which light bulb packs are at least 1 light bulb defective. So look at light bulb packs 1, 2, and 3. I'm buying a 5-pack of light bulbs. So there's bulbs inside of here. And in which light bulb packs is at least 1 light bulb broken, not working. Light bulb packs what and what have at least 1 light bulb that's broken. Light bulb packs what and what have at least 1 light bulb that's broken. I can change it around a little bit right here and change the way this one looks and still make the same thing. Ooh, let's do this. Oh no. Oh no, no, no. So it's still the same idea right here. 2 and 3, exactly. Great job, Reese, right there. So in light bulb packs 2 and 3, and still the same thing going on right here. There's at least 1 broken. Light bulb pack 3 is all broken light bulbs, which is very unlikely, but it could happen. Possible. More likely than winning the lottery. But we see there in light bulb pack 3, we got all broken light bulbs. In light bulb pack 1, we have all working light bulbs, denoted by the yellow highlighter. They're all working. It's just like that light bulb worked, and that light bulb worked, and that light bulb worked. And I'm saying and. Do you think a light bulb cares if the other light bulb works? What do you think each light bulb is of the other light bulbs? Each light bulb in this pack right here would be what? Like if we have a light bulb in here, that light bulb working would be what of the other light bulbs in the pack? Each light bulb working is a blank light bulb to another light bulb. And we're pretending they're not like from the same, like they were pulled off the same thing. Not quite disjoint. Not quite disjoint. Disjoint means if one works, the other can't work because they'd be disjoint event. Like one working means the other can't work. So if they're disjoint, they can't both work. Because when one happens, the other can't happen. They're independent. Great job, Reese, right there, 20 points. They're independent, which means knowing if one light bulb works, it doesn't give you any information about the other light bulb working. So if I have a 5-pack of light bulb, I'd be like, oh, this light bulb works, so that next one will definitely work. No, it's independent of the next one. Whether or not the next light bulb worked doesn't matter if this light bulb currently works. So each of these light bulbs here are independent. Now that means we can do what? And great practice right here. Since they're independent, what can we do right here to figure out the probability all of our light bulbs work? So I want to figure out the probability of all light bulbs working. What can we do since they're independent to figure out the first light bulb works? I'll write this down here in words. Good. So I want to figure out the first works, and second works, and third, and fourth, and fifth. What can I do to be like the first worked, and the second worked, and the third worked, and the fourth worked? And we know the probability of a light bulb working is 0.97. So the first worked, and the second worked, and the third worked, and the fourth worked, and the fifth light bulb worked. It's going to be this one up here. How can I figure that out? Because each one's independent of each other. So knowing that they're independent of each other, I can just do what with the probabilities to figure out the probability each light bulb works. Not add them because, so good work right there. Let's throw some 20 points. We're not going to add them because when we have independent events, here, I'll show it right here. Let's go to the notes on it. When we have independent events, we can multiply. So the keyword and right there, or is going to be addition. So when we see here, or, they're going to be disjoint, and we're going to, so we were going over this yesterday right here, where we have disjoint events, and we can add them when we have this or this. You can see the keyword there, or, and they have to be disjoint. Like you win or lose, that's disjoint. When we have multiplication, we're saying and. Like, what is the probability of getting heads and heads and heads, like on repeated coin flips? Not getting heads and tails, because you can't get heads and tails on a coin flip, but you could get heads and then flip again and get heads and then get heads and then get heads. So this is on repeated trials right here. Like, what's the probability a light bulb works, and then the next one works, and then the next one works, and the next one works. And that's what we're talking about here. The first works, and this and becomes a multiply right here, and we just put in the probabilities. So we're going to say the first works, and the second works, and the third works, and the fourth works, and all of these light bulbs work right here. So this turns out to be this right here, and this is key. Now, would you agree with me? Either all your light bulbs work, or what? Someone needs to put this in the chat right here. Either all your light bulbs will work. There's only two possibilities right here. Either all your light bulbs will work. So here's all your light bulbs are working, or what? It is the case that either all your light bulbs work, or what? Like, I buy my 5-pack of light bulbs, and either all my light bulbs will work. So either all work, or at least one broken. Exactly. Either all my light bulbs work, or at least one is broken. And let's change this. So all work, or, so the or is going to become a plus. At least one is broken is what we want to find. So this is what we want to find. All working is just going to be this. We figure out the probability all the light bulbs work. So here's the probability all the light bulbs work. And then let's just take this and algebra it over to the other side. And now at least one is broken. Great job, Layla, right there. Exactly. So the probability of at least one broken, so that says at least on broken. At least one broken is everything but all the light bulbs work. So everything but all the light bulbs work is at least one broken, because either they all work or at least one is broken. So every other thing except all the light bulbs work. So let's go ahead and solve this. Calculator right here works great for this. So 2, 3, 4, 5. 1 minus that, and copy, copy, copy. And that should do it. 3 decimals. I really love rounding on this site. There we go. Streak continues. Not getting anything wrong. Never again. Never again, my Pearson. And then Carly had one. Yeah, Carly's question. And then we'll do Leia's question. Let's hop over here to the main screen. Carly said chapter Canvas Content 6. We'll just do a few of those. We'll do a version of Canvas Content 6. Great work. Productive office hours. Love it. Canvas content number 6. Due tonight. Super important. Let's go ahead and grab this to the main screen. And let's do this. Okay. Statisticians select a representative sample from a large population they want to study by... True or false? That's why you're my song. True or false? That's ridiculous. True or false? What do you think? We use non-random methods. I mean, I guess someone could do that. I need to learn how to play that. What do you think? True or false? This is 100%. I see this on the test. I'd be like, false. This is false. Exactly. Oh no, we had a blip in the radar. So we are back. Weird stream disconnect. I do not know why Streamlabs does that. I don't know if it's YouTube, Streamlabs, or is if it's stupid Suddenlink. Sorry, Suddenlink. We pay you a lot of money. We do not want your service to be spotty. A researcher wants to examine the grams of fat in milk. They separate the milk into groups. And they have the 2%, the low fat. They randomly select cartons from each group to measure grams of fat. What are they doing? I don't want you to think about what answer this is right now. I want you to tell me what they are doing by separating the milk into groups. What are they doing by separating the milk into groups? It's so good to see you here, Charlie. Thank you, Charlie, for swinging by. What are they doing by separating the milk into groups? So they're first separating the milk into groups. So what are they doing by being like, okay, we have 2% and we have skim milk. We're going to then sample random cartons of milk to see the milk contents and stuff like that. Is this the question you're unsure about? Awesome. Glad we got it. So what are they doing by separating into group? That'd be true, Carly. Good question right there. That'd be true. Computer simulations are oftentimes like, we have computers simulate stuff. Like you'll see me simulate things like simulating the lottery and stuff. So that's what I try to do by like simulating stuff. Exactly. You will be so ready, Charlie. You'll be so ready. Are you taking the summer with me? Are you taking it summer session 1? Are you gonna be taking it here in like a few weeks? It'd be so crazy. Man, summer's such a good time to take classes. This is going to be stratified because they're acknowledging a difference to start. And so, yeah, Charlie, especially at the end next week, is going to be some really good knowledge for 320. Yeah. Oh, Charlie, and you're always welcome to swing by office hours and stuff like that. Next week, like, no, you're always welcome right now, too. I just don't want you to be like, next week, come by. No. You're doing 320 in the fall also, Sam. That's awesome. Yeah, and we'll be doing it here summer session 1. And I don't know. I'm going to be excited. I don't know. I like seeing repeat students. I'll be happy to see Charlie again. You're always welcome to swing by the YouTube channel. You're welcome to join in 201-324-74. Any conversations we're having, jump on in and be like, hey, I'm here to learn. The purpose of a sample is to have enough data to adequately describe the true or false. Is that part true? The purpose of a sample is to have enough data to adequately describe the what? Sample statistics give us insight into what? Dr. Demirke? He's great. I'll be working with Dr. Mirke and Nana Bryant, Dr. Bryant, and everyone's a doctor beside me. I think Dr. Panel also. Dr. Panel, Dr. Bryant, Dr. Demirke. I usually, I call them very well. I got to remember by the first names. Always, yeah, of course. And if you want to go into business analytics, yeah, you could be a TA for us and stuff like that. We usually take from the graduate students, but we also used to have helper students, and I missed that. And a few of them went on to go on to the MSBA program. SSPP. Oh, I already put that in the chat. That was me. Gosh, I don't remember that. Sample statistics give us insight into population parameters. So this is false because the purpose of a sample is to have enough data to adequately describe the population parameter to get inferential statistics. So that's very false. When a sample has characteristics which corresponds, it's going to be representative of the population. The sample is said to be representative. Bifurcated. What? Insignificant. No. Biased would not be good. Biased, it's the opposite of biased. I should do it. 10 out of 10. We're on a streak. Nothing wrong since Tuesday. Last week I just had to wake up. I hate getting questions wrong. I hate it. And then I start to spiral and I get more questions wrong. It's so sad. No. What questions are next? Let's see. Tara said false unless I want to skew that. I think we have Layla's question, right? I think Layla, we're up to your question. Layla's question was over investment. Yes, which websites, right? Which websites? Chapter 13, part 1. Let's head over here to Layla's question, chapter 13, part 1. And let's do this right here. If you ever have any ideas, for those who stream and stuff like that, I'm always trying to incorporate new ideas. I'm probably going to switch back over to to OBS and not Streamlabs OBS because I use Streamlabs OBS. The streamers are the only person who know what I'm talking about. But I keep thinking I need to switch back because there's some features I really want to try. Like if I switch back to OBS, I can actually do the Smash Bros thing, and that would be. See, now I just want to do this. I need to do it. So Charlie, really quick, Charlie, right here. You know, like Smash Bros when it does the freeze frame and it's like da 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 da. You know, like so and so enters the battle. I can do that if I use OBS. Like I understand what I have to do and the backgrounds I have to use, and how I have to freeze it. It just has those options. OBS actually has more plugins. It's got stream FX and all these different things. So I could actually do that. I could take this video right here of me right now and pause it and then move it. It'd be like Brian enters the battle. Yeah, exactly. I do have, because I worked on one of those really quick. Here, let's take a 2-second fun break. Then we're going to do Layla's question right here. But I made a video for those. Charlie might have saw this in his Stat Tool one. I worked on a video and I did that, where I did the Smash Bros thing, because mainly I just wanted to like... No, I didn't do it in that one. 2 seconds. Here it is. Found it. Oh, I was so happy with this. It took me like a whole weekend just to make a simple effect. So here it is right here. So actually, you know what I can do? Watch this. Oh, look at that. There it is right here. So here we go. I got so many different things. Now we're going to get DMCA'd. It's a bunch of moving backgrounds and stuff. Any coding with OBS? No coding, really. No coding. Oh, where's my Marvel? There we go. Okay, there we go. Okay, let's get serious here. But lots of fun, lots of good stuff right there. I don't know, have fun with OBS. Let's find Layla's question right here. A website is trying to figure out. Here we go. A new restaurant, a marketing, an investment website. Here we go. Time to do it. Thank you so much, Sam. But if I work on my OBS stuff, I could probably do that live. My microphone would be in. I just have to move the microphone out. You're welcome, Carly. Have a great day too. Let's get serious. Here we go. It's just fun to make things like that and then incorporate it. So that way we can have things like Puppet Shark. He doesn't appear nearly enough. Little Puppet Shark? Tiny Puppet Shark?
Tiny Brian.
Here we go. He appears in later lectures. So, I don't know, maybe I should introduce the cast of characters at the start of the semester. But yeah, I don't know. Might be a good idea. Okay, an investment website can tell what devices are used to access their site. The site managers wonder whether they should enhance the facilities for trading via smartphones, so they want to invest a proportion of users who can access their site. They draw a random sample. Ooh, random sample right there. Sample size. That's 277 for the sample size. Suppose the true proportion of smartphone users is 49%. Okay. So whenever I see this question, I really don't look at what they're asking first. I'm going to go over here, not there. I'm going to go over here, and I'm going to take all the information. I'm going to put it in, and then I'm going to start marking the notation. So the first thing we're going to do is we're going to mark notation, notation, notation. Help me out, everyone. I'll give you another one of these. I'll give you Q right here. Q is 0.51. And what is this? And this up here is equal to this. So right here, great job. This is N, and this is P. And great job, Sam. Perfect explanation right there. That is the true proportion, which means we know that. We're saying, like, we didn't get that from the sample. We're not saying 49% of the sample uses a smartphone, which this must be an old question because everyone uses a smartphone now. I got 1, 2, I could go grab like 3, 4, 5 smartphones. I've got all my old smartphones. I'm one of those people who doesn't trade in my smartphones. I'm like, I'll use these one day for like, I don't know. And then I don't. Now they're getting old. And I'm like, who wants to use an iPhone too? Not me. So we've got here the sample size. And then this is the truth. As in 49% of all people use a smartphone. We know nothing about this sample right now. We haven't talked about it. So let's go look at the question and see what it wants us to find out. It says, what would the managers expect the shape of the sampling distribution of the sample proportion to be? So if we meet all the conditions, which we do meet all the conditions, the shape for the distribution of the sampling distribution of the sample proportion with all the conditions met, will be, and the answer is right there. Meeting all the conditions, random, we take a random sample, less than 10%, and we have at least 10 successes, at least 10 failures, which we should. We have about 50-50, so we should have 140-ish successes, 140-ish failures, because there was almost 280 sample size. We would expect at least 10 successes, at least 10 failures. Hopefully it's a random sample, and we've taken less than 10% of all of our customers, so it should be unimodal and symmetric. They should just say normal right here, but that's what unimodal symmetric means. Awesome. What would the mean for the distribution be? This is where we have to do, great job, Layla, right there. Excellent work. Let's throw some 20 points. This is the easier question. And all it's asking is, if we know 20% of people use smartphones, then what percent of people in our sample would we expect to use smartphones? So this question right here is going to be mu p hat is equal to p. And this is going to be SD. The next one is SD p hat is equal to p times q over n square root. And great job. I think Layla got it right there. Excellent work, Layla. And I think the big thing, did you notice here, Layla? I think the biggest thing is once you have the notation, then it gets easier to solve. What do you think about this question right now? Like when you see the notation right here, which I'm blocking that. When you see the notation, I think the question gets way easier to solve. And so my hope is with the notation, 3% almost exactly. And the mean is 0.49, as long as I didn't make any mathematical errors. 3 decimal places, that should be it. Check answer. Yes, we're on our streak continues. Nothing wrong. I understand it. Yeah. Oh, right after you asked me to do it. No. No, I'm sure someone, probably the biggest thing for this question is the notation. So don't worry that you're like, I understand right after I ask you to do it. Someone's watching this video right now and being like, oh, I get it. The big thing's going to be knowing the notation. And so marking all the notation is going to be really big right here, finding your P, your Q, your N, plugging it into the formula to get the standard deviation, plugging it in. I mean, the mean is the mean, or the mean for the distribution of the sample proportion is the true proportion. So really great question. And we got an open floor for questions. We'll hop back here to space. So let's hop back here to space. What questions are there? Sam, Charlie, and Carly. Well, Carly left. But don't worry, if you're done with questions. Can you do the question in a new restaurant? That's a good one. Ooh, that's a tough one, Leanne. Great work. Chapter 7 homework? Wait, chapter 7? Chapter 7? Do you mean the Canvas content quiz? I could do it, chapter 7. An organization grade. Leanne and Reese got some questions right here. Let's go take a look at it. We'll do the restaurant one first, and then we'll do the next one. Okay, let's head over here to the main screen. 13. I was wondering too, Sam. I was like, I mean, there's chapter 7. Do some regression right here. Anything chapter 13 is fine. Awesome. Here we are with some chapter 13 right here. A new restaurant with 147 seats is being planned. So let's go ahead and take and mark some notation. Thank you so much, everyone, for putting answers in the chat right now. As you know, I like to have you figure out what the notation is. So I'm going to help you out once again by starting off the notation. We've got here this, and we've got here this. I'm going to derive for you this other thing. So you should kind of know. So put the notation in the chat right now. Because the first thing we're always going to do is we're going to mark the notation. So I found this by doing 1 minus this value. So the 0.38 is 1 minus 0.62. It's the complement of it. And so what are these values right here? So what are these values? We have that we are opening a restaurant with 147 size of amounts of things we're going to have in the restaurant, and studies show that 62%, so they're saying that's the truth. They're saying this is the truth, that 62% of people want smoke-free areas, which I don't know of any smoking restaurants right now. Leanne, you're totally right. This is N, and I'll go ahead and help out right here and put P right there. So that is P right there. P is the true proportion. And we could check the NP, NQ condition. You have the success failure condition right here that needs to be met. It needs to be a random sample of customers. It needs to be less than 10% of all customers. Assuming those conditions are true, we can also check here the success failure condition, and that's how many successes we expect. And these both need to be greater than 10. So all I'm doing is those are both greater than 10. And that means that the distribution should be approximately normal, which means I can use things like the David M. Lane applet, which are going to be a huge help and are going to be here in the chat. So I think, does this question ask you? No, it doesn't ask you to check the conditions, but I prefer to kind of look at my conditions and say, is this a random sample? I guess, kind of. Is it less than 10% of all people who would enter this restaurant? Yeah, 147 is probably less than 10%. And do we have at least 10 successes and at least 10 failures? Yes. Now the question asks for, we want the mean plus 3 standard deviations. So the important thing to know for this is going to be the mean plus 3 standard deviations. So the mean for the distribution is going to be mu p hat is equal to p. That's the mean right here. That's what it's talking about when it says the mean. And the standard deviation is going to be SD p hat. We could call it sigma 2 if we want. Equals p times q over n square root. So right here we have this, and let's go ahead and start solving these. Well, mu p hat, that's nice and easy. That's just p. I meant to say mu p. Mu p hat equals p. There we go. I can write it down. I just can't say it. And now we need to plug in these numbers. We're just plugging in the numbers. Remember, q is found by 1 minus p. They both add up to 1. They're complements. And there we go right there. So let's go ahead and solve the standard deviation. 0.62 times 0.38 divided by 147 p times q over n square root. Reese, that's some 50 points right there. Great job, Reese. Excellent work. Reese following along perfectly, earning some 50 points. Thank you, Reese. 4%. Oh, that makes life so easy, and it's almost perfect. Can I do this? I can almost do it in my head. It wants us to go up 3 standard deviations. Let's draw it out. We could have gone to the David M. Lane applet. Mine's almost exactly 4%. Be very careful. Carry your decimals. I'll do it on the calculator here too, but let's draw it visually. Here's the sampling distribution of the sample proportion. At the center of it is 62%. You can change it to a percentage if you want. It's a decimal since it's a proportion. But now I'm going up 4%, another 4%, another 4%. This distance right here, which was basically 4%, is the distance I'm going up each time because that's the standard deviation. So the standard deviation right there and the mean of the distribution right here is there. I know p hat is observed, but what exactly is definition of mu again? Expected, or the mean of the distribution for the sampling distribution of the sample proportion. It's a lot to say, but basically I like to just call it expected value. Like I expect in a sample to see 62% of people not wanting smoking because that's the truth. So this is the truth right here, but it's what we expect to see when we take a sample. So it is the full thing, like statistically speaking, would be the mean for the distribution of the sample proportion. So this is sample proportion, the mean for the distribution of the sample proportion. But rather than saying all of that, I like to say, I expect to see this in my sample. Like this is the expected value of a sample. Does that make sense? And we'll do, I think we'll do 2 more. We got the next 2. But does that, and then Reese has 1 too about the cars. We can definitely do that. And we'll come back to it, Reese. We'll get back to it. And we've got it in other videos, but I think we can definitely do that one today. We got more than enough time. Does that make sense, Sam, right there? Oh yeah, if you're 0.001 off, I'll just give it to you. Especially there's some on like 0.01. You're good. Does this make sense, Sam, right here when I call this what I expect to see when I take a sample? It's the mean for the distribution of the sample proportion, but it's the expected value of a sample. Like when I take a sample, this is what I expect to see. Since this is true, awesome. It's like I said today in lecture, the first year maybe I taught this, I don't think I understood it 100%. Do I understand it 100% now? Maybe I understand 99% of it now. It's like it's complex because it's theoretical. It's like saying if you take a sample, this is what you would expect to see. You're not taking a sample. It's just saying if you take a sample, this is what you expect to see. And we want to go up 3 standard deviations right now. Now here's what I'm going to do to check my mathematics. This is a standard deviation, 0.040003. I'm going to times it by 3, and if you notice, that's 12 higher. I'm going to add it to 0.62, so that's almost exactly what we have. And now here's the portion people get wrong. We need to now multiply it by the sample size of 147, and you have to do this with this number. That's how many seats we would expect. So that's 74% is 109 seats. Now, I got lucky, but you have to do this. Please notice this, and I'll probably give it to you if you get it wrong on this. What does it, just tell me if you get it wrong because of this. I think it's ridiculous. The question wants this. But what must you do with this number? Put it in the chat for someone who's about to answer this. If my answer was 108.1, what is my answer when I put this in? My answer was like 108.7, but it's still going to be the same answer. You round up. This is where a lot of mistakes occur. So this one, my answer is now, if this was my answer right here, what should Brian put right here in this box right here? What should I put? And look at this part here. This is where a lot of mistakes occur on this question. What is Brian going to put in this chat? Oh yeah, there you go. Sam sees it. You have to round up Please notice here the round up. That is just, if you get it wrong because of that, just email me. We'll say not today, my Pearson. Not today. You're not tricking us. You and your round up, not tricking us today. But that's very common mistake. Just email me if you round down. Like, don't round down if it's 107. Leanne, you got it. Yep, round up. So I'm glad we saved Leanne right there. But if you got it wrong, Leanne, because you're like, I didn't round up, I would just give the points back. I'd be like, yeah, sure, whatever. I think it's ridiculous that this question is that right there. They just like to see, you know what? I'm going to tell you a story. Here's story time with Brian. Here's story time with Brian. And then we're going to do another question right here. Here we go. Quick story time with Brian. You ready? When Brian was a little kid, he took a test. And the test said things like 9 times 9 equals, and then it had like A. And it had like 81, B. Had like 18, C. It's enough answers right there. 20. And then it said instructions at the top. It said circle all your answers below. I still remember this to this day. I took this test. And I went here and I said, what did I do? I can't remember what I did. I must have done something like this right here. I went and did that. And you know what the teacher did? I got my test back and the teacher said, nope. I said, what? I said 9 times 9 is 81. They said, you didn't circle your answer. I said, what? What? And they're like, you don't circle your answer, you don't get the points. And I was like, these things in education that shape us. This memory I have of a teacher who didn't give me credit for an answer I knew because I didn't circle the answer. I'm not that kind of teacher. If you know the answer, you get the points. Round up, round down, I don't care. I mean, round properly, but not today, my Pearson. Let's go to a question. We're not here to teach that way. We're here to teach to see if you know the material. So, do you mind looking at mine and see if I can get... Yeah. Send me a quick email, Layla. Or I can do that on like the next... If we get to a break point, I can do it during a break point, or send me a quick email saying, hey, Brian, can you look over that? I think, what was it? We've got the marketing researcher. I think we might be doing the marketing researcher. And then we get circled back because we've done the consumer. I don't think we've done the marketing researcher one yet. I always try to do as many new questions as we can, and then we circle back and do questions we've done. We haven't done marketing researcher. Ooh, this is a tricky one. Let's go do it. Another new question right here. Hey, Jonathan. So good to see you, Jonathan, in the chat. We're doing a little story time right there. So good to see you. Let's see. I love it when people swing by. This is a tough one. Let's do the market. Leanne's like, you bet. Marketing question. Let's do this. Let's do this. Marketing question. So we try to do as many new ones as we can. Then we're going to circle back. So Reese, we'll try to come back because that's a relevant test question. Reese, if you can't find the video for the car ones, we did a car one yesterday during office hours, and then we did the other car one at the very end of office hours today. So both car questions are in video format. Yesterday's office hours have the second car question, and then today's office hours, or today's class at the very end. It's not marked in the video yet, but the very end of class today has the other car question. So tell me if you can't find it, or we'll circle back here in a little bit if we have time today's office hours. So, oh, that's the one. Is this the one? Let's see how to do it. Okay. So this one right here seems more complicated than it is. A marketing researcher phone company surveys about 110. Surveys 110 people. Oh, there. I usually ask you that. And finds who are likely to switch when their contract expires is 20%. Okay, here we go. That's going to be... Is that from the sample? Yeah, it's from the... Yep. That is the truth right here. Okay, good. So with this one right here, there's a trick. Well, first off, let's find out the standard deviation. The standard deviation, and we need to find Q. Q is just going to be 0.80. So standard deviation of P hat, which it has right there, is P times Q over N square root. And 0.2 times 0.8 over 110 square root, and that is it. We found it. Should I show you the secret? What do you think? Should I show you the trick and solve this next one super quick? Or make an error on this question? Who thinks I should solve that next question in 2 seconds? Like, Brian, there's no way you can solve that next one in 2 seconds. I hope I didn't mis-enter something in. I've got a streak going. I can't lose my streak. That's right, right? I think, right? Yeah, 4 decimals. Cool. Should I show you the trick? Trick or no trick? Trick or treat? Should we do it? Should I show you the trick on how to... if I show you the trick, you'll never want to actually solve it. It's a cool trick. Here we go. We're speedrunning this question. You ready? Start the clock. There we go. Boom. Solved. You might notice the relationship that it has to 110. Let's show why Brian was able to know that this is 440. So it says, if she wants to reduce the standard deviation by half, how large of a sample would she need to take? So here's her original standard deviation. Let's go look at the formulas we have because it'll show why this works. So the formula for the standard deviation, you can see right there, is P times Q over N square root. P times Q. And Sam and Reese are like, do it. We did it. So she wants to reduce this by half. This is her goal. So since she wants to reduce this by half, can I just take this 1/2 and just multiply this in right here? Can this just go into the radical, yes or no? Can this just go into the radical? Can this just like be like, wah, just go inside of here? And then I could just rewrite this. I could just be like, okay, let's go right here and algebra it and just go right here and do this and put the 1 here and put the 2 there. Does that work? You can't do that. That's not good algebra. That doesn't work. Well, let's rewrite this. Let's go here and rewrite this as the following. Square root of P times Q over N times, and let's go here, square root of 1. That's still 1. Square root of 1 is like, that's the same thing. And square root of 4. What's the square root of 4 again? Like, look at this right here, and look at this right here, and look at this right here, and look at this right here. Have I written the same? Have I written the same thing? Wrote. Did I write the same thing? That's the same thing. And now, this can go over. Well, not go away. This can go over here because it's got the square root. It can go inside there with that. Delete the radical. So now this can go inside of there, and that can go inside of there. And all Brian did was take the sample size and do what? So when Brian saw the sample size was 110, we got it marked up there. The sample, it might be hard to see. The sample size is 110. So when Brian saw the sample size was 110, all he did was do what to that? To figure out how to get half the standard deviation. Because our goal right here is to get half the standard deviation. That's our goal, is to get half the standard deviation. So to achieve that goal, all we need to do is what? To achieve the goal of half the standard deviation, because we want it to be half the size of what it was, all we have to do is what? To achieve the goal of half the standard deviation, we just multiply the sample size by what? I'll show you something interesting here in a moment. To achieve the goal of half the standard deviation, we just multiply it by... It's the answer down there. What if you wanted your standard deviation to be 1/10 of what it was? How much more of a sample would you have to take if you wanted your standard deviation to be 1/10 of what it was? Like you wanted it to be 1/10. Like this is saying you want a much, much smaller standard deviation. How much larger of a sample would you need to decrease your standard deviation to 10% of its original value? So you're saying, I've got this much variation in my data. I want to get 10% of that variation. Like I want it to have only 10% of its original variation. So how much larger of a sample would you need? And just think what's going to follow through as I solve down this. How much more of a sample would you need if your goal is to have 10% of your original variation, which that's what standard deviation is. Yep, Sam's seeing it. Great job. And so yeah, you'd have to take 100 times more observations. So you can see it's like a diminishing return. that to decrease the variation, you have to have exponential growth to your sample size. To get half the standard deviation, half the variation, you have to take 4 times the sample. To get a third of it, you have to get 9 times. To get a fourth of it, you have to get 16 times your sample. So you have to collect a lot more data to reduce the variation. It's diminishing returns with larger samples. So that's why people don't go and collect like 50,000 observations. Sometimes you'll collect like 2,000 and be like, that's enough, because it's diminishing returns on like your variation in your data. Because you don't want variation. You want like your data to tell you what's going on, and you don't want it to have like uncertainty, variation in it. And that's what the standard deviation is. It's uncertainty. It's variation in the data. So that's got it. I think we had another one here, right? Was there another chapter 13 question? And then I think we might do Reese's question next, because we could hop back to the car questions. What else was there in chapter 13? Let me see, because we've done almost, let's see here. We just did number. Have we done? We did the bank question. We did the school referendum. We haven't done the philanthropic. That's a multiple choice. We haven't done the nearsighted children. We could do nearsighted. So 13.1 quiz question exercise 3. Let's do it. Here we go. 13. This is homework, right? Based on past experience. Yep, we can do that one next here, Leanne. We did that one during class. Do not worry though. We can do it. I always want to, we'll always do every new question, then we'll circle back here. So that way they're all in the videos. Yay! That's always my goal, to do as many new questions as we can do. And we haven't done the homework one yet, probably. Let me look at Sam's. And then we'll do Leanne's, or we'll do Reese's next, because Reese had a repeat question. And then we'll do Leanne's question. So stay tuned. Chapter 13 homework. And we're doing sampling, distributions, and proportion. Okay, here we go. Yep, philanthropic organization, is it? Is it the philanthropic? Or did you say question 3? When they send out the fundraising letter? Which one is it, Sam, do you want us to do? 13.1 quiz exercise 3. Can you put the star of the question? I've got here based on past experience from a bank, which it might be also the one. I know for part C, we use the online Z table. I was just curious if you use below or average to find the probability of over 18%. You'll use above. You'll use above. So you're doing the bank one, right? Yep, you'll do like above 18%. So you'll do to the right of, you'll do above. So great job, Leanne, right there. Which one starts out when they send a fundraising letter? Okay, cool. Oh, wait. Are you doing 13.2, right? Oh, no. Here it is right here. I found it. Oh, here's the question. Yep. Great job, Leanne. Excellent work. And here we are with this question right here. When they send out a fundraising letter, a philanthropic organization gets returns from about 5%. So that's probably their P right there. To see the response rate might be in the future, they did a simulation. Ooh, simulation. For each sample size, they simulated 1,000 mailings with a success rate of 5%. Constructed the histograms. Okay, so it's going to be interesting. Explain how these histograms demonstrate the central limit theorem. So they're going to, as you increase the sample size, the distributions will look more what and more what. There's 2 things to the central limit theorem. And I'll say them right here, and then I want you to notice them. The distributions are going to look more normal. These are the 2 things for the central limit theorem. And they're also going to be tighter. The reason they're going to be tighter is because of the way the formula works with the square root of n. By increasing n, you're decreasing the standard deviation. And then the last thing, the reason they look more normal, do we still have that web page up from earlier? We do. The reason they look more normal is because we passed the success-failure condition. When we fail the success-failure condition, things will look skewed. The larger or the more successes we have, when we have successes and failures greater than or 10, when we have more than 10 successes, awesome, Leanne, great job. When we have successes and failures greater than 10, it'll look normal. So you notice here, when we don't have enough successes and we don't have enough failures, it doesn't look normal. But as you start to get more successes, that was a wrong button. As you start to get more successes, which you can see the successes going up, you're starting to see it become more normal looking. So as we get more successes, the distribution starts to become more normal. To where finally, when we have enough successes, at least 10 successes and at least 10 failures calculated by NQ, you just take the complement of that, then we would say we meet the it's going to look normal. I shouldn't say nearly normal. It's going to look approximately normal. More on other conditions later. Contact, don't be weird. And so now, as the sample size increases, the histograms, and notice right here, let's show it. Why can't you just full screen this? They look more normal. There's a small sample 20, 50, 100, 200. Ooh, starts to look pretty normal. So the sample distributions are going to, the center. The center does not move. And what is this talking about? The center not moving is the mean for the distribution of the sample proportion. And we have that on here somewhere, don't we? There it is right here. The sample size does not come into play right here. N is not part of this equation when we figure out the mean for the distribution. So as the sample size increases, the mean will stay the same. There's no calculation done right here for the mean for the distribution with N. It doesn't matter what the sample size is. The sample size will matter down here when we're calculating the standard deviation, but the center of the distribution is going to not move mathematically. The shape of the distribution becomes more normal, and the variability, which is just the standard deviation, is going to get smaller. So when it says variability, it's just talking about the standard deviations. Simulations do show what's true, and so that should work. Excellent work. Does that make more sense, Sam, right there as we talk through this? Does that make more sense? And then Leanne and Reese had a question. If you have a question, let me know, and I'll see. I think Leanne got hers right. We might jump to Reese's question. But put your question in the chat. We can definitely do an old question right now if you're doing the car question or if you're doing the bank question. What question do you want to do? We still got 24 minutes left of office hours, so we can definitely go back and do some old questions. If there's no old questions, we could do retos. So we'll try to focus to chapter 2. Awesome. You're welcome, Sam. So are you done with Sam? Great work. I try to encourage people, especially next week, coming to office hours is going to be key to just getting the work done. Take a look at the questions, come to office hours, get the work done. Boom, you're good. Work done for the day. So great job, Sam. See you later. Enjoy your day. Let me know which questions you have. I'm trying to think, which other ones have we not done? We haven't done this one yet. So I'll do this one and then put a question in the chat and we'll do that next. We haven't done the nearsighted children problem. Let me put a cut in the video. It's time for the nearsighted children problem. Let's head over here and do this. Here we go. Okay. It is believed, they're stating that that is true. So this is going to be P right here. It is believed that 10% of children are nearsighted. And as we always do, we're just going to take and grab this info and bring it over here. So, way too far zoomed out. It is believed that 10% of children are nearsighted. And we're going to go out and take a sample of 192. So since we're saying that this is the truth, that is P. Now, instantaneously, once we find P, we should find Q. Q is just the complement, which is just 1 minus it. We have right here 192, which is going to be N. And there's 192. So now I can kind of tell what this question is going to go. It's going to ask us for the mean and for the standard deviation of the sampling distribution of the sample proportion, which is what would happen when we take a sample of 192 children and see if they're nearsighted. So we know that the mean for the distribution of the sample proportion is P hat, or is P, excuse me, and the standard deviation of P hat is P times Q, and you will be given these formulas over N square root. So awesome, Layla, great work right there. Let's plug in the numbers and solve the answers. 10%. And disappear. P times Q over N square root. P times Q over N square root. There we go. And that is the number. There we go. We have the mean and we have the standard deviation for the distribution of the sample proportion. And there's a mistake that's commonly made on this problem, but we know the mean, we know the standard deviation. Oh my gosh, so much jump. And what does it say? I always hate when it says assume the conditions are met. Yeah, sure. Yeah, assume they're typical. Sure. Random 10% success failure. Now here's where the mistake's usually made. We're going up and down 3 standard deviations. So if you take the mean of 10% and you go up and down 3 standard deviations, so it has to be the one right here behind my head or this one right here. This is way too small of a standard deviation. I don't even know why this is a wrong answer because it's way too small. If you were to multiply this by 3 right here, then you would see it's 6 point. And are they not carrying their decimals? You carry your decimals, my Pearson. But yeah, I always want to talk to them about these things. They're like, how is this being generated? Because that's not. Did I do mine correctly? I'm gonna check my numbers. Let's go P times Q over N square root. I think I did something wrong. P times Q over N square root. That looks better. Yeah, they're not carrying decimals. That's weird. I don't know why. Or maybe, you know what they may be doing? I bet you it's this. Yeah, that's what they've done. They've rounded this number. They round this to 2 decimals, and then they multiply. So they do the rounding. I never realized that till right now, why sometimes these answers are slightly different. And I don't like that. I don't like that they're rounding it and then multiplying it. No, you only round at the end. So I should talk to whoever wrote this code. I should reach out to them. But that's 3 standard deviations up, 1, 2, 3 up, 1, 2, 3 down. And that's the answer for that one. Going down further, how many children? So we're looking here at the proportion. So we'd expect 16%. That's the upper bound out of 192. It's almost 200, so we could multiply that by 2 and see it's about 32. But let's show it. Out of 192 children, I'd expect at most about 16.6%. And that's the 32. Out of 192 children, I'd expect the minimum to be about this, and that's about 7. So there we go. Good stuff right there. We did the bank problem earlier. We did the referendum. And we haven't done this one yet. Here, we'll hop back here. Let's do this last one, and then we'll have all the homework done. So check out the videos. All the homework problems done. Okay, and questions are open right now. So if you have a question, put it in the chat. The questions are currently open. Let's hop here and do the last problem on the homework. Here we go. The proportion of adult women in a certain geographic region is about 49%. A marketing survey telephones 300 people at random. You knew what happened there. What proportion of the sample would you expect to be women? I mean, 49% of them are women. So if 49% are women, I mean, there you go. I mean, it tells me that 49% are women. So the last part right here, is this the last part? There might be another question after this. What would the standard deviation be? This is P times Q over N square root. Just so you can see, I'm going to pull up the notes on this. This question right now is going over the notes we went over today on how to find these portions right here. There's the P times Q over N square root. So plugging in the numbers right here, they're telling me that the truth is 0.49. And so we'll just delete that for the moment. They're telling me the truth. Oh, we just put that up here. Let's do that. The proportion of women is 49%. Proportions are decimals. And so we have this right here. The sample size is 300. And that doesn't matter for this portion. But hopefully this helps with the notes right here to see it. So we're just doing the notes right here. We're putting this in so we can see how this is being done. There's P times Q over N square root. P times Q over N. Q is the complement. And there's the N. So just seeing this right here, how this question is solved. They've sampled 300 women. They're saying here's the variation down at the bottom. They're saying this is what they expect because that's the mean for the distribution of the sample proportion is the true proportion. And then the standard deviation for the distribution of the sample proportion is P times Q over N square root. And let's go ahead and solve this. P times Q over N square root. And there it is. There's the standard deviation. And we'll go back here. And round to 3 decimals. I was afraid I'm going to make a mistake there. There we go. How many women, on average, would you expect to find in a sample that size? So that's just taking the proportion right here and multiplying it by 300. So it says how many women are... Yeah, sure. So if 49% women, so 147? Yeah. Yep. Always try to maybe solve it in your head for a moment to see if you're getting it right. Similar question, we got it. So I was just saying if we expect 49%, so I'd expect 147 women because that's 49%. Layla right there to the next level. Brian tier. There's more tiers after that even to come. So keep going. Keep getting higher and higher tiers. But are there any questions? Reese, do you still have the car question? We've got it in another video. So we'll head over here, put on a little music. We'll see if people have questions right now. Let me know if you have questions. You're welcome, Layla. Thank you. I just want to keep offering the advice to be successful. And I love it when people give advice, like especially at the start of class. I always want students to talk to students. If you want, Reese, do you want me to do it, Reese? Which one are you working on? I'll work on it right now. Like I'm totally happy to work on things when people are here. Like I might not have worked on it if you're not here because it's in a video then. You'd either watch it later or watch it now. Are you working on the we can work on it right now because we still got 15 minutes. So let's do it. So wait, and you can ask like what you're stuck on and we can make sure you get it and you get it. Because the point of these office hours is for you to get the work done. You get the work done, you're free for the rest of the day, like or get as much work done. It helps review the concepts. So you're doing the right thing here, Reese. So let's hop here and do it. And thank you for waiting, especially. Like I said, I always try to do as many new questions as we can, but I'm more than happy to do an old question. So we always try to do all the new material, like the ones we haven't done yet. And then we circle back and we say, you waited, and we will do that question. I always appreciate how positive. Let me hop over here and we'll see which one we're doing. Okay. Is it this one right here where it asks about, is it version, this is version A, where it says no repairs, or is it version B where it says neither will be repaired? Is it version A? So just put A or B in the chat. Is your version that you're working on right now version A where it says no repairs, or version B where it says neither will be repaired? So version A or version B? Version A was done today. I'm gonna do it again right here, but version A was done today in class at the end. Version B was done yesterday during office hours. So here's this is version B right now, where it says neither will be repaired. And here, version B, let's do it. Version B is the harder one. Good, people are gonna like this, because this is the tough one. Maybe I didn't explain it so perfectly yesterday, so let's try this again right here. This is the tougher one. The other one is the addition rule. This one's the multiplication rule. If you're wondering about version A, and you're like, oh, no, I wanted to do version A. Here's the summary of version A. Check it out from today's today's class. You can see how we're using the addition rule to add together things, and the addition rule is disjoint. The rule you're going to hear for this one is going to be the multiplication rule. This is the other version of the question. So let's go ahead and start graphing this out similarly, but start using the multiplication rule. Now for this question, you own 2 cars. Here's your 2 cars, your space cars, Cybertrucks. Here's your 2 cars, car number 1 and car number 2. You got your 2 cars. With your 2 cars right here, we need to know the probability they need repairs. The probability, we got to move these cars over. There we go, perfect. The probability your car needs 1 repair is up here. You'll notice it says right here, the probability it needs 1 repair is equal to 20%. The probability it needs 2 repairs is equal to 7%. Probability 3 or more repairs is equal to 2%. And the only probability we're missing right now is the probability it needs how many repairs. And I'll say that part. What's the probability, Reese, it needs 0 repairs? So you're saying like one of your cars needs 0 repairs. So what's the probability of that? And this is the complement rule, because I'll show you right here. I'll zoom out just a little bit on this. This is the complement rule because the probability of repairs. So this is the probability of repairs now. We have either your car gets repairs. So we could say the probability of a car getting a repair in a year, like getting any sort of repairs, is this. And so is that, did I do it? Ah, you're close. So either there's the probability of repairs. So either the car gets 1, 2, or 3 repairs. So the probability of repairs is 29%. The probability of no repairs is what? 71. Great job right there, Charlie, practicing up. This will come into play in a lot of our classes, the complement and probability. So very important right here. The probability of repairs is 29%. No, you're fine. Don't worry about it. It's practice. You know, we're going to reward everyone with 20 points right there, Charlie. You know how it goes in this class. We don't care if you get a wrong answer. We're here to practice, and the way to practice is just to put wrong answers sometimes, and then we say, wait a minute. We're going to take the complement. Either the car gets repairs or it gets no repairs, and those are complements of each other. So these questions are a little bit complex. The first one says, what is the probability that neither of your cars will need repairs? So my first car did not need a repair, and my second car did not need a repair. My first car did not need a... Oh, wait. It was probably neither car. Yeah. So my first car did not need a repair, and my second car did not need a repair. So how are we going to find this? And apparently these are independent things, like your first car needing repair and your second car needing repair. We're assuming independence right here. So let's put here at the top so everyone knows this one is mainly about the multiplication rule. It's kind of a hint. Multiplication. So the first car did not need repairs. Is it that? So the first car did not need repairs and the second car did not need repairs. Your first car does not need repairs and your second car. Oh, good job. Yeah. I was like, that's interesting. I think that sounds right because 7 times 7 is 49. So it's going to be a little bit bigger. Great job. Great job right there. What we're doing right now to solve this, and I think we can get this perfectly on the screen. Oh, so close. So this is the first question right here. This is equal to, just we're drawing it out visually and then we're solving it. 0.79 times 0.79. Such your first car does not need repairs and your second car does not need repairs. Can you do the canvas response bias is always possible? Yep. Very true right there. Response bias is when people put biases in their response. So very, very possible. Always possible. Great question right there. That is always possible, Leanne. Good question. There's the probability that both your cars need repairs. The next question reads the probability that neither will need repairs. Oh, no. I just did it. Wait. That both will need repairs. Oh my gosh, my brain broke. The probability that both your cars need repairs is this right here. So let's put a check mark on it. So this is your car needing repairs. Both cars need repairs. So the first need repairs and the second need repairs. So we'll do this in green right here. What is the probability for both your cars needing repairs? The first car needs repairs and the second car needs repairs. The first car needed repairs and the second car needed some repairs. Like, exactly, I think you're getting it right there. Because there's the probability of the first one needing some sort of repairs and the second one needing. When I say and, we multiply. You have to assume they're independent of each other, so we got that right there. And now we're on to the final question, and this is the tough one. Now, there's a bunch of scenarios here. We got to make this smaller. Oh, really? There we go. Okay, so we're going to make this smaller right here. And I want you to see this. There's a few scenarios that can occur right here. Here's all the scenarios that can occur. This is the sample space. So let's write sample space above this. So here's the sample space. The sample space is everything that can occur. It's different from the sample frame, which is everything we can draw from. I know I'm drawing like a frame right here, but this is the sample space. The sample space adds up to what? Go ahead and put in the chat what the sample space adds up to. The sample space adds up to what? So we're visually drawing this out right here to make sense of it. The sample space adds up to what? Like when you talk about everything in the sample space, it adds up to what? Like all the possibilities of the sample space have a probability of what if we add them up. Like if I go this or this or this, like I start adding these all up right here. I say this or this or this, I start adding them up. They have a possibility of 1. So when you look at this right here, I want you to look at the sample space. We want to know the probability of at least one of your cars getting repairs. We are interested in this right here. The last question says, what's the probability that at least one of your cars gets repairs? What is the only thing we're not interested in? When we talk about the sample space, everything right here. Because either this or at least one of your cars gets repairs. So either this happens or at least one of your cars gets repairs. So look at what we have. We have everything that could occur like none of your cars gets repairs. Your first car does not get repairs. Your second car gets a repair. Your first car gets a repair. Your second one does not. Well, so don't think about the percent right here. You're close right there, Charlie. You're so close. Because this right here, if I do the probabilities, here, let me see. I might have miscommunicated this. Might have done better yesterday. If I draw this out with the probabilities below here, it's going to look a little smaller. This one right here, which will slide it off right here. Don't worry about the size of it. This is that first probability we found of 5, 0, and 4, 1. So that's that probability right there. How could you find the probability of the shaded area? This might help right here to see this. What is the probability of this over here? Because either your cars get no repairs or at least one of them gets a repair. Is this making more sense right here? Either neither of your cars get repairs or at least one gets repairs. So that's visually what we're trying to find right there. We're trying to find what's the probability at least one of your cars gets repaired, which is this or this or this or this. Yep, does that, so hopefully seeing it right here, be like, oh, either neither of my cars get repairs or at least one get repairs. So does this visual make sense right here? Like these are your two cars, neither of them got repairs, or it could be the case that at least one of them got a repair. Like the first did not get a repair, but the second did. The first got a repair, the second did not, or both of them could get repairs. And then it's the complement because everything here is equal to 1. So whatever is over here, because they're all disjoint, has to equal up to 1. So everyone is correct right there in the chat. I hate how it does that. And this would be 0.4959 right there. There we go. That's the answer to the last one right there. That's the probability at least one of your cars gets repairs. And so this was the answer to the first question up top. The second and the third is the tougher one. So I'll mark them on here. This is how the first one is done. Neither of your cars need repairs. Here's the second one. Both of your cars need repairs. And here's the third one. At least one of your cars need repairs. Last question, of course. The Lego group maker of plastic neurocells individual Lego minifigures. Yeah, let's do it right here. We'll do it, Leon. You got it. So this right here, let's put these answers into the question. And let's solve it right here. Okay. So the probability neither will need repairs is this. We just found that. The probability both will need repairs. I'm trusting everyone right here. Was it? I'm afraid. Is it? I'm going to double check. I don't. We're on a streak right now. Okay, good. There it is right there. 0.841. It says do not round. It says do not round. It says do not round. Do not round. So don't round these answers. We're going to double check the other one. Don't round your answers. There we go. It says do not round. Would the streak have been over if we had rounded this? This doesn't count for losing the streak. We haven't had a wrong answer since Tuesday, I think. Please tell me if you would have rounded that. Please tell me. Don't round it. It said don't round. Would have gotten mad if we do this. Does it get mad if you do that? Okay, good. Oh, I'm just having some fun in the background right there. Let's over to Leanne's question on the Canvas content. Okay, here we go. We're going to hop over to the Canvas content. And 2 seconds, I'm going to get the Canvas content up and going. Canvas content. This is the randomness Canvas content. I'm going to have some soup today. I've got some really good soup. Yes, this is the randomness one. Okay, here we go. I got to find the Lego one. Oh my gosh, it's the first question. Let's do it. It was destined to be. No, that doesn't count, Reese. That doesn't count against the streak. The streak is still going. We haven't gotten a question wrong since Tuesday. It might have been like, I think it was, I don't know. Someone has to go back and check the video. Someone have to tell me. Based on simulation, what proportion of the time do you estimate you will find at least one of each figure? So we are going to go right here. Lot of information in this question. Lot of information. Let's go over to Word so we can mark it. So we want to find at least one of each figure. And so when we do these trials right here, probably the easiest thing to do is just to see if there's no Peyton Mannings. Peyton Manning's number 9. So let's see right here. This one is no Peyton Mannings. This one's no Peyton Mannings. And all the others have Peyton Mannings. Let's check for Mulans. Mulans are 7 and 8s. We only need to check the ones we don't. Oh, there's no Mulan in this one. And what other simulation has no Mulans? I'm going to ask you. I need help for the chat right now. What other simulation here has no Mulans? Because we want to see that there's at least one Mulan in all these simulations. There's a simulation I need to check down here. One of these simulations down below does not have a Mulan. So which of these simulations, 5, 6, 7, or 8, does not have a Mulan in it? I got the hiccups today. Which of these simulations does not have a Mulan in it? Run 7. Great job, Leanne, right there. Next, we're going to check for Alexander Hamilton's. 4, 5, 6. So there's an Alexander. 4, 5, 6. There's an Alexander. Uh-oh. No 4, 5, 6. That's a no. And then we need to check for LeBron. LeBron, and LeBron. These 2s represent LeBrons right there. So the answer is, as long as I haven't made an error, Does that make sense right there? I go through checking it by just eliminating the ones like there's no Peyton, those don't have all of them. There's no Moulins, those they don't have it. There's no Alexanders, so then we just check for LeBron in the remaining ones. So you can just go through and be like, does it have this? Nope, eliminated. But yeah, that should do it. Perfect timing. So it should be 3 out of 7. We're only checking this one. This 3 out of 8. That is correct, right? Please, streak, don't end. We need to get a 2 out of 10 on this. 2 out of 10 to keep the streak. 2 out of 10. Streak maintains. 3 out of 8. Yep. So visually speaking over here, we have 3 out of 8. How could we make this simulation better? Increase the trials. We could increase the trials right here. I'd be interested to run this and see what I don't know. Not that it matters. I want to know if they did a random number generation for this. I should ask the person who made it. Like, did you random number generate, or was this all from your head? Because it's a little weird to me that there are a bunch of 9s. I mean, he is Peyton Manning, so he should be in all the packs, all the Lego packs. But that's got it. You're welcome, Leanne. Great work. We'll head over here to space. We'll play the usual ending song. Well, that's got it. I'm going to make it so Mewbot can appear in this world. I figured, oh, he has to be a global thing then. He has to have his own scene. That's a lot of work. I might work on that. Be longer than it would take right now, so I can make Mewbot appear at any time. I have my own global. I can remove myself, but I can't make Mewbot appear globally yet. Ellie should be Ellie. Who? Eli Manning? Eli Manning, yeah, not Ellie. Eli from the Giants right there. I'm surprised I even know that. I only know that because he's tangential to Peyton. So then I know Eli Manning, of course. Man, I don't know Eli Manning. But that's got it. Good stuff. I'll work on getting Mewbot to appear in all universes. So a Mewbot can appear at any time we want. He can appear in this universe. A little more work right now to get him to appear. Mewbot's always over here, though. Unless he's evil Mewbot. We don't see evil Mewbot nearly enough either. We don't see the boss. Maybe we'll see the boss for tomorrow. Be putting those questions in Discord because I'm going to take them from tonight. But that's got it. We'll be back. I'm going to go grab some lunch. You're welcome, Reese. Great job. Keep up the great work. We'll be back. Turn in the project, everybody. Get ready for Project 2. It'll come out this weekend, so take a look at it this weekend and ask those questions. With that, we'll be back later. Bye for now, everyone. Bye. Bye, Mewbot.
I am Mewbot.